Good afternoon. My
Good morning.
name is Robert Levy. I'm a program manager on the Surface SDK team. I've got Anson here with me.
I'm Anson Chow. I'm a program manager for the WPF team, responsible for multi-touch.
And we're going to talk to you today as .NET developers about what you need to know for developing on Microsoft Surface as well as on Windows 7. We're really excited to be here today, day 3 of PDC. We've got lots of new touch developers now. You guys got cool devices. I'm excited that it's day 3 because that means that we don't have to wear these same shirts again tomorrow. So let's get started. What we're going to talk about, we do a quick introduction of multi-touch, where this stuff all came from, what you should be thinking about. And then Anson's going to come and talk about the multi-touch capabilities that are built into WPF4 and Silverlight 3 for use on Windows 7. He'll go into the raw input APIs, manipulation and inertia for things like gestures, as well as some gestures that are enabled in certain WPF controls. And then I'll come back up and go into how Surface actually has a bunch of additional controls for multi-touch and even goes beyond multi-touch into a whole new dimension. We'll wrap things up by showing how Microsoft is creating alignment between Windows and Surface by using WPF4 as a common baseline multi-touch API. We'll show some obligatory slides that the PDC organizer stuck at the end of our deck that are very enjoyable, so stay around for those. And then we'll do some question and answer at the end. So multi-touch. Multi-touch is important because it fundamentally creates a whole new world of opportunities for us as software developers. It gives us the opportunity to create software applications that are, one, intuitive for users. They can walk up and quickly learn how to interact with these systems. They can discover the advanced capabilities of these systems very quickly and efficiently and become expert users because all you have to do is touch and do gestures. It also gives us the opportunity to create a whole new category of applications that are collaborative and that multiple users can gather around a single device and interact with it simultaneously together. That said, this multi-touch world isn't actually anything new. Researchers and academics have been doing this stuff for decades. Bill Buxton from Microsoft has a blog where he's posted the history of multi-touch, and he has academic research papers and videos that have been published for a long, long time, way, way back to even before I was born. People have been working on this multi-touch stuff. But now, today, multi-touch is ready to go mainstream. And the reason I say that is because we have a couple of key ingredients that are starting to come together. One is the hardware. We've got some awesome hardware. Microsoft has been selling multi-touch hardware with the Surface product for a couple of years now. It's really robust, and it's doing quite well. And now with the introduction of Windows 7, there's tons more multi-touch devices that are out in the market. There's already 24 or more multi-touch certified Windows 7 devices that you can go to stores and purchase today, or you can just use the ones that we gave out to you yesterday, whatever. We have a great operating system that has multi-touch support baked into it, top to bottom. And then what's important to developers is the SDKs. We've got great SDKs with the native APIs that are in Windows 7, as well as the .NET story that Anson and I will be talking about today for Surface and Windows with WPF, Silverlight, things like that. And the most important ingredient is you guys, right? We got a room full of people who are excited and passionate about multi-touch and doing awesome things with it, seeing the opportunities that are being created with these new categories and ways that you can bring this into your business and do things that weren't possible before. You can solve old problems in new, better, more exciting ways, and you can solve a whole new category of problems, open up new business opportunities. At Microsoft, the Surface team has been working on multi-touch for quite a while now. We've become a thought leader in this space by building out a great multi-touch development platform. Back when we started a few years ago, there was no Windows 7 or WPF4 with touch built in. So what we ended up doing is using WPF 3.5 and building up our own little input stack and input APIs and UI framework that extended WPF to enable multi-touch development. But now there is Windows 7, and there is WPF4. So what Anson and I have been doing since we were at PDC last year, we've been working very closely, meeting all the time, taking lots of the technology from Microsoft Surface that was extending WPF 3.5 and actually moving that directly into WPF4. So over time, what's going to happen is we're going to have this common baseline platform so that developers can target Windows 7 or Microsoft Surface by using the same APIs inside of WPF4. So with that, I'd actually like to pass the remote over to Anson to talk about the APIs that are inside of WPF4. Clicker's not working.
Oh, thank you, Robin. So how many of you guys went to the Windows Touch Deep Dive yesterday? OK, great, thank you. OK, so we're really excited about multi-touch capabilities in WPF4. We had the opportunity of taking a lot of the learnings from Surface, but this time around, we can really actually build it into the framework that makes using multi-touch on the .NET platform a lot easier. So what I'll be talking about is the multi-touch infrastructure that we've added in that really supports this broad spectrum of devices with Windows 7 and Surface and perhaps other devices in the future as well. So let's take a quick overview of what type of features we've added into WPF. So with Beta 1, we introduced the high-level manipulation events. Manipulation events are the high-level events that allow custom controls to do pan, zoom, and rotate gestures. And how many of you have picked up Beta 1 and looked at these APIs? So we've actually made quite a few changes in the APIs into Beta 2. So in Beta 2, we've basically completed the API set that's necessary to write custom controls with multi-touch. We've added the raw touch events that gives you access to individual touch contacts. We've also added the extensible touch device infrastructure. So this infrastructure allows us to support both Windows 7 device and Surface devices. And this is an open API that other people can add to as well. And we also recognize that not everybody is going to be writing custom controls that use multi-touch. We want to make sure that existing WPF controls can take advantage of the touch hardware that people will be getting on the machine. So we want to make sure that out of the box, WPF applications have good touch experience. So post Beta 2, we've added support for touch panning to the intrinsic controls that is part of WPF. So we've added touch panning for list box, text box, etc. And finally, when Surface comes out, they will be integrating into the extensible touch device infrastructure, and the same APIs that you use to write controls for Windows 7 will be the same APIs that you use to write controls for Surface. So let's take a look at some code on what writing WPF touch controls would be like. So we'll start by looking at the raw touch APIs. The raw touch APIs are the equivalent of your mouse events in WPF. So just like mouse events, you get touch down, touch move, and touch up events. And you also get the equivalents of the preview events and touch enter and touch leave. The big difference between mouse and touch is that you have multiple touch devices on a multi-touch machine. In a touch device, you get one touch device per touch contact. And it's important as you're writing multi-touch applications using these touch events to keep track of the touch devices. And each touch device have a unique ID. And you can also use the touch device itself as the key to the, to recognize which touch device you're working with. So in this particular example, I have a simple canvas, and I'm responding to the touch down, touch move, and touch up events. And this particular demo is very simple. All I'm doing is tracking touch movement on the canvas and moving around the various shapes to indicate where your touch contacts are. Let's take a look at the code itself. So for the touchdown events, the first thing that we do is that we create a shape for that particular touch contact. And this is just a utility class in this particular demo app that creates a circle. and assign a color to it. So the next thing that we do is we get the touch point for this particular event. The touch point is equivalent to a position on the mouse. And touch point returns your position information as well as size position, the size information. And on devices such as Surface, you may also get additional information about your particular touch contact for this particular event. So we get the touch point, have the coordinate system relative to the canvas. And then all we're doing here is really just transforming the circle to the position of your touch point. And finally, we add that particular shape to the canvas, and then we also stash away the shape so that when we do the next move, we can just update that shape. We also capture the touch contact on the canvas so that you don't have to do hit testing. So one of the differences between mouse events and touch events is that for multi-touch events, we support multiple capture. So each UI element can capture more than one touch device, and multiple UI elements can capture touch devices simultaneously. What this enables is to have multiple active control so that you can have a collaborative environment such as on Surface. Whereas with the mouse, there's only one primary mouse device, and you can only have one button being clicked at one time. So for touch move, we check to see if the device has been captured to a canvas, and then we retrieve from the dictionary the particular shape associated with this touch device. We update the location of this particular shape and apply the transformation. And finally, on the touch up, we release the touch capture from the canvas of this particular device, and then we just do cleanup. So for WPF and Silverlight, we also expose a lower level touch APIs that are common to both platforms. So if you want to write multi-touch applications that are both usable on WPF and Silverlight, you can use this low-level API that we call Touch Frame Reported event. This event puts together a group of touch events up, down, and move, and report them at the application level. In WPF, with the touch events, they get routed through your visual tree, but with the low-level events, they're not routed. You capture that at the application level. And the manipulation events on WPF for pan, zoom, and rotate are based on the manipulation process and inertia processor that's applied by Surface. And we've built that into part of .NET 4. And in the case of Silverlight 3, we make that as a separate download available on surface.com. So let's take a quick look at the API for the frame reported API. So first, you hook up the frame reported event at the application level. And then as you respond to the event, you enumerate through the various touch points. So each touch point is a separate contact at that particular point in time. And you get the touch action property tells you whether this particular touch contact is up, down, or being moved. So let's move a little bit high level and look at the WPF manipulation events. As I mentioned before, manipulation events are the high-level events that lets you respond to pan, zoom, and rotate. And the example I'm going to give here is a simple example on how to write an application that pan, zooms, and rotates a photograph. And I will be showing, and this particular, yeah, gotcha. Thank you.
Don't have you, sorry. Still don't have you.
There we go. And in this particular example, I've put an image on the canvas, and the image I've moved it 200 pixels by 200 pixels, so that it's somewhat centered on the screen. Nice cute koala bear. And so let's actually add the code that we need to pan, zoom, and rotate this particular image. So to do that, there are two events that you need to handle for manipulation, minimum of two events you need to handle for manipulation. The first event is the manipulation starting event. So the manipulation starting event gives you an opportunity of configuring how the manipulation inertia processor handles the touch input for this particular element. And in order to get these events, you need to tell the system that I am watching for these events on this particular element. And the way you do that is that you specify the is manipulation enabled event to true. And this is a property on the UI element. So with this event, with this property set, these elements will be waiting for the touch events, and if you don't handle these touch events, the underlying manipulation logic will pick up the events, capture the touch devices to this particular element, and start generating the pan, zoom, and rotate manipulation events. So in the manipulation starting event, what you need to do is to specify the particular manipulation container that this element is relative to. A manipulation container specifies the coordinate system that this element is moving against. So this allows us to report events to you to support, to tell the transformation pan, zoom, and rotate to a fixed area. So this is a difference in beta 1 where we didn't have to specify this. And when we specify the manipulation container, you can have nested manipulations so that I can actually manipulate an element that is also being manipulated. So in this case, I'm going to set the canvas as the manipulation container. And the next event I need to handle is the manipulation delta event. And the delta event is equivalent of the move event that get reported every time there is a change in pan, zoom, and rotate. And I have some boilerplate code here that first looks at the original source of this event that gives us the element that this event came from. And this is the element that has the is manipulation enabled set to true. And then we're going to extract the transformation from this element, because the way that we're going to apply the pan, zoom, and rotate is to update the render transform. And this is just one way of applying the transformation. You can use other mechanism to actually implement the pan, zoom, and rotate. And in this particular case, we expect a matrix transformation out of the render transform, and we're going to extract the matrix from that. So the next thing we need to do is to actually apply the transformation from the manipulation event. And so the first thing we're going to do is we're going to scale, and then we're going to rotate, and we're going to pan the element. So the manipulation event returns either the cumulative manipulation, that's the transformation since the start of the manipulation, as well as the delta manipulation, which is the manipulation, the transformation since last event that you've received. And in this case, we'll be using the delta manipulation. And we'll look at the scale. We're going to apply the scale for x and y. And we're going to center the scale at the manipulation origin. And we're going to do the same for rotation. Delta manipulation, and this time we're going to pick up the rotation property. And we're going to center at the manipulation origin. And finally, we're going to do the translation. So this is panning. And we're going to pick up the translation.x and translation.y. And then we're going to apply this new matrix transform into the render transform. Thank you. And we're done. And with this amount of code, we will get pan, zoom, and rotate on the elements. So let's quickly recap what we did there. So first, for the elements that wants to get the manipulation that are being manipulated, we set the is manipulation enabled. And then we handle the manipulation starting event, and we set the container to the fixed base that these manipulations are relative to. In this particular case, the canvas. And then we handle the manipulation delta event, and then we apply the render transform in this particular case to the elements that we want to show the translation. We've also incorporated inertia support directly into these manipulation events. So that allows us to have a really good user experience where after you've removed all the touch contacts, you get a smooth transition to stopping based on inertia and friction. And let's take a look at the code example for that. So this example is based on the last one that we had, and we're responding to one additional event. In this particular case is the manipulation inertia starting event. And this event gets called at the end of your direct manipulation. It gets called and gives you an opportunity to configure the inertia parameters for the rest of the movement of the elements that you're dealing with. So to respond to the event, you get given in the event arguments, you get given the initial velocity, and you can configure your inertia for translation, rotation, and scaling. In this case, we would do a inertia for translation. So responding to the manipulation inertia starting event argument, we're going to set the translation behavior. And we're going to set the desired deceleration. We're not going to change the initial velocity, and we're going to specify the deceleration based on pixels per millisecond squared. So in this particular case, we'll pick 0.001. And let's run the app and see what happens. So this particular application basically dropped a few more images on the screen. And you can use, and you can pan, zoom, and rotate just as before. And we've also added inertia. So in this case, we can just fling the elements, and they go off screen. So you notice that there's no boundary. You actually don't want your elements to just fly off screen. So you want to be able to kind of build a boundary around these. Around this the canvas. So using the start manipulation method inside the manipulation inertia starting event arguments and the deltas, you can actually initiate new inertia movements during the movement of your elements. In this particular case, I have some utility class that helps us. First, during the manipulation delta. I want to check to see if I have moved this element off screen. And I'm going to check that and start a bounce when that happens. So I have a method called check bounce. We'll take a look at that. And check bounce will initiate a new inertia so that it bounces back from the boundary. And we're going to apply the bounce during the inertia starting event. So let's take a look at how we implemented these methods. So in the check bounce method, first we basically get the element bounce of the element that you're looking at. And we're doing simple check against whether the element bounds have moved past the left, moved up the top, and moved past the right and bottom. And then at the end of that, we call the start inertia method on the event argument. What that does, that initiates a new phase of inertia. And in the apply bounce method, we take what we have stored for the for which boundary edge that we're bouncing off, and we change the initial velocity of your translation behavior, and we basically reflect it. If you're bouncing off left and right, we reflect the x initial velocity, and if it's top and bottom, we reflect the y initial velocity. And we finally also kind of increase the deceleration so it slows down a bit. So with this code, now we can we have boundary feedback for being able to bounce off boundaries. So just to summarize, we support translation behavior, rotation behavior, and expansion behavior for inertia. And the units are based on the device-independent pixels in WPF and milliseconds. And we support the desired deceleration that allows you to specify the rate of deceleration for the particular inertial movement. Or the desired displacement. Displacements allow you to stop the elements at a particular distance. So for example, if I'm using inertia to flip pages, I want to make sure that I'm not panning past the end of the page. I want my page to stop at the exactly right spot. And I can be using displacement instead of deceleration for that effect. So manipulation is really a state machine, and we can quickly go through what it looks like. So we've responded to a starting event that allows you to initialize the manipulation processor. The started event get called once on the first time that manipulation happened, and you get a series of delta events. And as you remove all your fingers from the touch device, you get an inertia starting event that allows you to configure inertia. And if you have inertia, you get another series of delta events. And when all the movement has stopped, you get the completed event. And during these events, you have opportunities of, during the delta events, you get the opportunity of starting inertia, such as what we saw during the bouncing off the boundary. You also have the opportunity of completing and canceling the manipulation during any time of this state machine. So with touch and manipulation, you get the low-level infrastructure to build custom controls. And but in order to support out-of-the-box touch experience, we've also added touch panning directly into WPF controls. And I'll quickly go through that. So with Listbox, you get touch panning and also with text box. So we get the basic out-of-the-box experience for touch. One difference that WPF has with native controls is that we support multiple manipulations at the same time. So this allows you to have multiple people collaborating on the same display surface. So this touch panning support, if you guys have picked up Beta 2, you actually won't see that. The next release that we have will incorporate this functionality. Along with that, we added the cancel method that allows you to cancel an existing manipulation and promote to mouse. So that gives you a way of incorporating existing controls that are not touch enabled into your custom controls. And we've added touch panning support directly into the scroll viewers so that you can enable panning and touch panning in both directions, as well as doing what we saw on the text box, where we only look for touch panning in one of the directions and then promote to mouse in the other one. And finally, we've added the styling changes that for intrinsic controls that configures the scroll viewer.
So, Anton, I think I love the touch APIs that you guys have built. Really easy to use. I love the manipulation and inertia stuff, easier than anything we've ever had in the past. I also love how you've taken the basic controls like scroll viewer and text box and added panning support to those so that out of the box people just recompile their Windows apps and now they get some basic touch manipulation things. On Surface, though, we've actually gone a bit farther. For people who want to build applications that are truly optimized for touch all up, instead of just getting some magic gesture support added to their scrolling components.
So why don't you show us what you guys have?
I would love to do so. So in Surface, over time, we built up a large suite of controls that are really designed for multi-touch. An example of what that means is that if you put 2 fingers down on a button control and only lift one of them up, we won't send a click event on the button. But if you had a button control that was based on mouse events, then you wouldn't get that behavior. It would click immediately. We also have controls that are designed inherently for simultaneous use. WPF has done this with the scroll viewer. We've gone and done it with everything else. So you can click 2 buttons at the same time, move to sliders at the same time, do anything you want at the same time, which is important for multi-user environments. We've also gone and added manipulation and inertia all over the place. We think that manipulation and inertia, that's like the fundamental gestures for multi-touch, and we bake those into all of our controls, not just scroll viewer, but also things like slider and scroll bar and some custom controls. So actually, let me walk through a couple examples of what it means to use these Surface controls. So Anson, you did a demo where you were tracking the low-level touch up, down, changed events. Right. Often when people do that on Surface, it's because they want to build a simple like inking application for annotation, things like that. If somebody working with the Surface controls wanted to do inking, annotation, drawing, there's actually only a couple of steps you have to take. Step 1 is to instantiate an instance of the Surface ink canvas control. Step 2 is to go home. You're done. That's all it takes. Right? You add the Surface ink canvas control, and you automatically get support for multiple input on an ink canvas. And since this is derived from the Windows ink canvas control, that means that you can do everything with this that you could do with that, such as handwriting recognition. Right? And we also base the size of the stroke based on the thickness of the finger, so how much of your finger is in contact with the screen. Another example is manipulating photos. The manipulation APIs are really great, very powerful, but often people don't want to have to write that amount of code, especially because there's trigonometry involved. I know that intimidates me, which is why devs I work with on the Surface SDK team have created what we call the scatter view control. Scatter view is a control that derives from items control, which means you work with it the same way that you work with other items controls like list box or tree view or menu. Meaning you populate it with items, and then you supply a template for how you want each of those items to get rendered. So in this particular example, if we want to manipulate photos, we'd simply set up a data template that has a WPF image element, and we pull in the file name for those things. And then we data bind this thing by setting the item source to a collection of image file names. That's all it takes to get the equivalent of what Anson was showing with manipulation APIs. It has inertia built in, it has other things like drop shadows built in, some really great bouncing feedback, great Z-order management, things like that, all built into the scatter view control. We can actually go to the next level and combine these things, right? So on this slide, I've got the same scatter view control, but added some space because we can insert some stuff. The first thing we can insert is we can add a surface ink canvas control into our scatter view right on top of the photo. So now we have a photo, we can also ink and annotate and draw on top of it. And then we just add some glue to tie those two things together. We also have a special version of the scroll viewer for Surface, which instead of sending boundary feedback up to the operating system to jiggle your window, we have elasticity built into the scroll viewer itself. So I can actually wrap my scatter view in a scroll viewer. And now what I have is a canvas that can be panned around with some good elastic feedback and manipulatable photos, which can also be inked on. All of this with a few lines of XAML and one line of code. And if you'd like, I can actually, I'm going to assume you'd like, I can show you this running on Surface. So what I have here is that code already running. Hit F5. And now we get our canvas that I can pan around. We get that elastic feedback on the edge. Our photos are scatter view items that we can resize, rotate, spin around. We got the inertia. And of course, we can do the multi-touch inking on them. So really simple, just one line of code, few lines of XAML. Yeah? Yeah?
You make that look easy.
You like that, but you also have Win 7 touch devices. So I'm really excited to announce that we're going to hook you guys up, those of you who want to target Windows 7 in addition to Microsoft Surface. So what we're going to do, we're going to take all of the WPF 3.5 multi-touch controls we built in the Surface SDK. We're porting those over to WPF4 and we're going to build that on top of the low-level touch and manipulation APIs that Anson showed. We're going to bundle that up into a package we call the Surface Toolkit for Windows Touch. And then around the same time, when Visual Studio 2010 RTMs early next year, we'll make this package available so you can use the Surface Touch controls in your Windows 7 applications. So you'll be able to use the same controls in both places. Yeah, it's pretty exciting. So let me show you exactly what's going to be in that package. Right, we're going to start by taking all the controls that Surface has built that derive from things already in WPF, where we add the multi-touch behaviors to them. Things like window, where we automatically make things go full screen, button, where we do the two-finger click thing, slider, scroll viewer, ink canvas, checkbox, all these common controls that we made work really, really well, optimized for multi-touch. Next up are controls that we created from scratch, brand new things that are designed solely for multi-touch. The scatter view is a really good example, probably the most popular one. Another thing we have in here are what we call the library controls, the library bar, the library stack, and a couple of other things that bring those two together. The library stack acts as a UI collection for objects where things show stacked on top of each other and the user can tap and flick through to iterate and sort through this collection. The library bar is very similar, but instead of showing items stacked on top of each other, it shows them in a grid that the user can scroll through, and there's some sorting and filtering functionality built into those controls. But wait, there is more. Oh yes, there's more. We also have some really core UX framework functionality that's essential for multi-touch. First up is a rich asynchronous drag and drop framework. The traditional drag and drop framework is meant to be driven by a mouse, which means that you can only have one of them going at a time. That doesn't work well in a multi-touch world. It also assumes that you actually have a cursor, a small cursor that's like a little tiny gray box representing the thing that's being dragged, which also doesn't work well in a multi-touch world. In multi-touch, we want to have multiple drag and drops going on simultaneously, and you want rich visuals that are actually interactive while they're being dragged. So Surface has created a set of APIs that look very similar to the existing mouse-based drag and drop framework, but it solves these problems for you. Then we've also got something that we call input visualizations. We learned that when we give users visual feedback in a consistent way to every time they touch the surface, they learn very quickly some of the quirks of how that system works, how hard they need to touch, how soft they need to touch, if if a large part of their finger comes in contact with the screen, what part of that finger is being used for hit testing. So what we do is we provide a consistent layer of visual feedback for every touch, and that's built into this toolkit that we'll be providing. So some of you don't look like you believe me. Actually, you do. But I'm going to assume you don't and show you. I'm going to move over to Anson's machine where he has the exact same code up that I showed running on the Surface, except his is WPF4 with an early version of our toolkit. I'm going to hit F5, and we get the exact same thing. So I get my scroll viewer where we can do the panning. We get the elasticity. We've got our scatter view items that we can move around, rotate, resize, and of course do the multi-touch inking. So the exact same stuff that you're really excited about on Surface, now on Windows 7. So we're doing a lot of stuff to standardize the stuff that should be standardized around basic multi-touch. Windows 7, WPF4, and this toolkit are going to make a really great baseline for building killer multi-touch applications. That said, Surface is really about way more than multi-touch. We've designed our hardware to have a really robust tabletop, a horizontal form factor, and an array of infrared cameras under the cover. Let me show you what that gives us. It gives us the ability to do what we call massive multi-touch, the ability to have multi-user experiences, the ability to do object recognition, and something that I'll just call optical engineering magic. Let's dig into each of these. First is multi-user. And this is the reason why I came to the Surface team, what I'm really, really passionate about. There's a trend in technology today where we're building solutions, we're building software that reduces the need for people to have face-to-face interactions. Right? We do more online sitting in front of our terminals or our laptops instead of going and interacting with real people. And this is a problem, right? It makes us more efficient in some ways in the business world, but it's also a problem because we know that human happiness and human creativity depends on having these social interactions with other people. And Surface lets us break that trend. It lets us take things in the other direction. Our industrial design, the fact that we are horizontal, the height that we've chosen, the width of that lip around the edge of the surface was designed precisely to encourage people to gather around all sides of the unit, facing each other, and using the software as a tool to facilitate face-to-face collaborations. We also have the input capabilities that enable people to interact simultaneously. There's no turn taking. Everybody can jump in at the exact same time. And we have partners who are building killer applications that really, really facilitate this kind of collaboration and friendly competition. This is, of course, enabled by our ability to do what we call massive multi-touch. Often when people talk about multi-touch, they mean 2 inputs or 4 inputs or 10 inputs. On Surface, we stop counting after 52 inputs. But that's enough to enable some really cool applications. This is a photo that was taken earlier at the conference, people playing the tiles game that's out there on the floor. Next up is object recognition. We have these things we call optical tags. You place them on the bottom of an object, and when Surface sees it, it can tell you the ID that tag represents. We've got 2 types of tags. The first type are byte tags. Byte tags are a byte, so there's 256 unique values. Earlier this year, we introduced a new type of tag that has a slightly larger range of possible values. So there's actually a GUID that's encoded in these tags. And if you go down to the first floor by the registration desk, you can pick up a business card that has one of these tags on the back of it. So when Surface sees one of these tags, it tells your application, here's the input I see, here's where it is, here's the unique value representing it, so your application can do cool stuff. Surface also reports up to the application, here's the orientation of that object, here's what direction it's facing. Next up is optics. This is kind of the most underestimated attribute of Surface. What I have here is an image of what Surface sees when you put 2 hands flat down on the surface. We're able to see everything that's going on right on top of the display. And this means that we're able to, 1, determine the shape and size of every input that's there, not just where it is. And we're able to see into the inside of certain objects and project onto certain objects. That sounds kind of weird, so I think I'll just do a demo. This is where the optical magic comes in. Close this application. We'll go into another one. Actually, let me set this up a little bit. What I have, we took one of these lamps, these cheesy kind of lamps. I've never put one in my house, but I found a good place to put one. If you take these little strands of fiber optic fibers, you cut them off, you bundle them up, and then you take a little toy, a children's toy, you drill a hole, you cut out the toy's face. We like to cut things a lot on Surface. Cut a hole in his face and push those fibers through his face and into his bottom. So what that means, because there's fiber optics here, let's see if I can show this well. Because there's fiber optics here, any light that comes into the bottom of my toy is going to show up on his face. So when I put this guy down, Surface can project underneath him, and cool stuff will happen.
Thirsty. Where is my cup?
So we've got a little monster. He's got an eyeball. He's blinking. He's wagging his tail. We can move him around. Let's see his back. So that's like $1.50 worth of materials there, right? There's no batteries, there's no electronics, but this is a more engaging toy than I've ever seen before. Now, our monster, I call him Vanessa. Our monster asked us to give him a cup. Let me go back this way. I happen to have a cup here that I will give our monster.
I am still thirsty. Please fill my cup.
So our monster knows that I'm kind of toying with him. I gave him a cup, but the cup is empty. We're not fulfilling his thirst. So
I am thirsty. Where is my cup?
I'll get back to you. So the reason he knows his cup is empty is because this cup, also $1.50 worth of materials, has a prism built into the bottom of it. And there's some fancy optical engineering things that I don't understand and won't try to explain to you. But what happens is that infrared light from Surface shines into the cup, and if the cup is empty, the prism reflects that light back down. If the cup is full, that light just passes through the water and out into the world. So the Surface is able to know whether a cup is full or empty. So actually, let me put my cup down again.
I am still thirsty. Please fill my cup.
And I opened up a camera view, what the Surface sees underneath this cup, so I can rotate around. You can see that's live. Grab some water. And the red that you see is the infrared light that's getting reflected back from the cup, from that prism. So as I fill this cup up, we'll see that red go away. We'll also change the visuals under the cup.
Thank you very much. I will keep an eye on my drink.
So he says thank you. He's a very gracious monster. And he also says he's going to keep his eye on his drink. That's because not only do we have two physical objects that are being lit up by the virtual world, these two physical objects now interact with each other via the Surface. So as I move the cup around, you'll notice that his eyeball will follow. Turns out our monster is also very good at that shell game. So if we were going to try to confuse it, we could, and he's able to follow our cup. Can't beat him that way.
I am thirsty.
All right,
Where is my
we're done
cup?
with that. All right, so you guys clap. There's no standing ovation, and I know what it means when I do a demo. There's no standing ovation. No, that's okay. It's okay. No. It means that you don't really see how it's super practical to have a monster whose eyeball lights up in your businesses. That's fine. What I can do, though, is show you a quick video of some ways that our partners have leveraged physical objects and applications that they have built. So that's a tagged object that as it rotates, the software does some magnification on the thing that it's placed over. Here we're using physical cards and tokens in a business environment to guide users through understanding a portfolio of services that a company has to offer. This was actually the winner of a developer contest that we recently finished up. Here's an example of using physical objects as dials to configure virtual objects and make selections. So you just rotate the object, use the orientation value from the tag, and do great stuff with that. Here's an example of using physical objects that have some optical capabilities built into them. So Surface not only sees the object itself, but it sees what's on top of that object, which works great in checker games. It also works for things like Legos, where the Surface now knows where what things are stacked on top of what other things. So we're seeing multiple levels in 3 dimensions on the Surface. Here we're taking a partner's taking a scan of a book that's placed on the Surface, figuring out what book that is, and presenting the user with more information about it and related things. This one's really cool, picking up a leaf off the ground, placing it on the Surface, recognizing the shape of that leaf, and then using that to determine what that leaf is and present users with more information about that plant. So those are the kinds of things, practical things, that our partners are doing today, shipping applications on Microsoft Surface. I can talk real quick about how we're going to build on top of the WPF4 input infrastructure and expose to applications a Surface-specific input data. I'm going to fly through this because we're a little short on time. But essentially what we're going to do is we're going to plug into WPF's input manager for sending basic touch input. And then we're building a set of extension methods for apps to reach out and get extra data like the orientation or tag data. So for example, if I want to get the position of an input, I'll call the standard WPF touch.getPosition API. If I want to get something Surface-specific, I can call into some static extension methods. Microsoft Surface, touch extensions, get tag data, pass in my touch, and that will return back the tag data. But because of some new magic in C# extension method syntax, that can all be shortened to touch.getTagData. Behind the scenes, the compiler will turn this line of code into being equivalent of the one before it. And then the same technique applies for getting orientation of Surface inputs, ellipse, shape, other stuff like that. All right, so our roadmap. This is where we are today. If you want to build something on a shipping platform, we've got Windows 7, we've got Microsoft Surface, and WPF 3.5. So on Windows 7, there's really no great managed story right now. That'll come with the introduction of WPF 4 early next year, as well as the Surface Toolkit. So at that point, we're taking a lot of the technology from Surface, as we promised last year at PDC, and standardizing that across the company so that you can use very similar concepts on both places. Now, you see here, though, that we're still not super unified. You can't use the exact same code on both places, because Surface, we're still at V1, we're still using WPF 3.5, and that's where the next version of Surface is going to come in. We're going to have an awesome unified story, where regardless of whether you're targeting Windows 7 touch hardware or you're targeting Microsoft Surface hardware, you use the exact same touch APIs from WPF 4 and the exact same controls from the Surface Toolkit for Windows Touch. So we've talked a lot about software. You're probably wondering what's new for hardware at Microsoft Surface. We get this question all the time. I'm not really allowed to announce anything today, but I can say 3 things that we're definitely exploring very vigorously. One is getting things cheaper, getting that cost down. 2 is getting things thinner. And 3 is giving our partners the option of taking the Surface hardware and putting it in vertical settings. So stay tuned for more on that. Now, call to action. What can we do together? If you want to develop for Windows 7, get started today. You can grab the Silverlight 3 RTM bits that have the touch APIs Anson mentioned. You can get the beta bits that also have those same APIs built into them. You can get WPF 4.0 in Visual Studio 2010 Beta 2. Some great stuff going there, and I encourage you to start working with that and learning those APIs. On Surface, we have an invitation-only program on community.surface.com, where our partners are able to go get the Surface SDK, get a simulator tool that we have so you can do Surface development on a standard PC. We've got lots of samples, templates, docs, forums, things like that. You guys are a lot nicer than the last audience where I presented this slide. We got a lot of groans when I said the words invitation only. I appreciate you being nice, and as a thank you gift, we're changing things up. We actually made this change yesterday. So now the Surface SDK V1, all the resources around it, documentation, forums, all that stuff, we're ditching the private lockdown community site, and we're integrating with MSDN and TechNet. So this stuff is free for all. If you want the links to it, just go to surface.com, whack developer, and there's links to the different places across MSDN and TechNet and MSDN communities where you can get at the Surface technology. And of course, if you want to buy hardware, order forms on surface.com. Related resources. There was a session earlier in the week on native code for Windows Touch done by Reed. It was a great session. If you're interested in doing Touch on Win 7 with native code, definitely go watch the recording of that. More information on WPF4 is on connect.microsoft.com, whack WPF. Lots of Surface stuff on surface.com if you want to learn more about that technology. I want to give 2 shout-outs to some of our partners. One is Infragistics. They have a booth in the big room where they're demonstrating 3 controls they built for Surface that are being given away for free. And that includes a map control, a carousel control, and a chart control. They're pretty cool. Check them out. Again, they're free. And also, our friends at N2 Solutions are writing a book on Surface development. This is not available yet. I've been told that it's coming within the next few weeks, and that you can watch for that on n2solutions.com/surfacebook. We're doing a user research study to learn more about people who are interested in Touch from a developer perspective. Go to won'ttakelong.com, and you can win a $50 gift card and help us do a better job of serving you. And of course, for this session in particular, your feedback is very important to us. It tells us how we can deliver better content, what you enjoyed, what you didn't, whether we should be allowed out of our cages ever again. It's also good for the children, right? Every time you fill out an eval, the children get $1 from the Boys and Girls Club. It's pretty cool.
And I think you get $2
if somebody fills out 5 evals, they get $2. So with that, we can take questions. Please use the mics. Thanks. Any questions?
I've got one.
Oh, great.
Over here.
Oh, all right.
I have a Surface at work that we just got, and yes, it's excellent. And I would like to consider putting a better platform on it than Vista 32-bit.
So,
any suggestions?
So what we support on Surface V1 is Windows Vista, SP1, 32-bit.
Right.
And we have an end-to-end experience that's really crafted to work well with that.
Okay.
So that's what we support at this time. In the future, we're definitely going to be moving to 64-bit, Windows 7, latest and greatest everything.
Okay, thank you.
You talked about integrating the Surface stuff with WPF. Is there any plans for Silverlight?
So we definitely want to get there. We definitely want to get more and more of this technology into Silverlight. The Silverlight guys did a great job with their basic touch APIs that are there now.
Yeah, they, we're working very closely with them to the API that we have in WPF are, that design is usable on Silverlight, and we'll see when it makes sense for Silverlight to pick up the APIs. So
I think once there's more parity between WPF and Silverlight APIs, when Silverlight has all the stuff that WPF has, then we're definitely interested in getting our controls ported over to that platform as well.
All right. Currently, I'd say the most available devices that run any form of Windows would be cell phones. Any plans on moving this to the compact version of .NET?
We definitely talk with the Windows Mobile folks, and we have a goal of getting the platform unified across the company. I don't have anything to announce on that front today, but it's definitely something that we want to get unification across the entire company.
Okay. I had one more. When I played around with the tablet that we got yesterday, multi-touch actually seems more to get in the way than, because you can't use a device that big. If I want to write on it, I want to rest my hand on it. And with the multi-touch, it registers my hand and I can't do anything. Am I missing something?
Yeah, I mean, there are different types of tablets. The touch-enabled tablets, as well as the active tablets, that works better with an active pen that tracks your current position. So, so we support both platforms. It depends on the hardware manufacturers to see what direction that that they're interested in. With multi-touch, yes, it's you're not going to get the inking resolution that you get with an active pen.
I also think a lot of it's going to come down to having applications that are really optimized, designed for touch from the ground up, right? And we don't have a lot of that yet, and that's where you guys come in, right? Using the APIs that we were talking about. We need to get those
but just
applications.
using Windows, like clicking the top left icon on the window is really tricky when I can't rest my hand on it in portrait mode. Just a note from my perspective.
Thank you.
Thank you.
With the touch stuff in WPF, is there a commanding structure, or is it all just routed events?
These are routed events. You can obviously use the WPF. You can initiate like WPF commands based on those. These events are also usable in triggers.
Cool. All right. Thank you, guys.
Thank you.
We'll be outside if anybody else has more questions you want to follow up on. Thanks.